We're going to start off with a speed round, which means that they have to have super quick, fast, one word, one sentence answers. You ready? No. Okay, true or false, and we're just going to go down the line. Joe, Alexey, Rick, okay? So true or false, we are preparing for 2023 to be better than 2022. Joe, go.
Depends on what happens.
Oh, that's whoa. Did you not hear the rules?
Okay.
Okay, and it was true or false?
True.
Okay.
Absolutely.
True.
What one word, I'm underlining that, describes what will be needed to address today's housing needs?
Industrialization.
Calibration.
Standardization.
Which stakeholder in the home building ecosystem will have the most impact on delivering the needed supply?
The developer.
Us.
Manufacturing.
What will be the biggest challenge meeting supply in the next year or 2 years? Rising costs, labor, lack of innovation, regulation, policy?
All of the above. But labor is a big issue.
Yeah.
I would say all of them, depending on where you are.
All but policy.
You're saying a special focus on policy. Yeah. Not except policy.
Exactly.
Yeah. Okay. Perfect.
Special focus.
How would you relate the words housing and factory?
Inseparable.
Nice.
I would say it's a future.
Sorry?
It's a future.
Yeah. Future.
Optimum building.
Yeah. Okay. All right. Now, we're warmed up. Okay. Joe, you've worn a lot of hats, and I want to give you the opportunity to talk about all of them because you have a lot of things going, just like Alexey. But one thing in particular that, really relevant to this session and this panel right now is getting the costs down. So while average cost per square foot for construction right now across the country is close to $250. But you have a project that is a smart home and you're delivering for under $100 a square foot. And so I'm showing pictures of that. So how did you get there?
Scrutinizing the on-site building process, the inefficiencies there's so many, but then also developing little by little. It's been a lot of work. We've been working for 3 years on this to fine-tune it's a small scale, it's not like Rick's, but the assembly line to speed up the process, to make the process more efficient. The challenge, of course, with prefab is how you overcome the overhead costs of having a factory now and the overhead costs of the cost of transporting the modules to the site. But once you overcome that, you're golden, and it only gets leaner and leaner and leaner as you go and as you fine tune that process. We're trying to get to the apples to apples, but then the added benefit can be all of the advantages to being in a factory, which is the ability to now install, tighter, or to have tighter buildings, to install more technology, to have greener, houses, right? It's an ideal environment.
Yeah, so in the picture here, how many of you have seen a modular or been involved in a modular prefab project? Okay, so a majority. Okay, great. So how complete is that unit that's being dropped down by the crane right now on the picture?
That's about 80% when we're done. We try to complete as much as possible, especially the kitchens and bathrooms, to get it to where, everything's complete. The advantage Rick has with these volumetric is everything in there is pretty much finished from the inside. And that's kind of the goal, is to start from the ground up. You can't go in and slice and dice a modular project. You have to really think about the design. The designers have to understand how this building is going to go together, as you're designing it. So it's just very efficient.
Yeah, and then when you're on these job sites too, and I guess a lot of you probably already know this because you've been involved in these projects, but when you're on this job site, there's literally no scrap at all. Like there's no waste on the job site at all. So Alexey's working on something that's a little bit unique as well, and you're using 3D printing in a new way to solve for design and efficiency and sustainability.
So in our operation, we actually, as I said, so we introduce a new material, and I believe in a way of kind of like, what if we use way less material to deliver the same results? So, meaning, first of all, like additive manufacturing, meaning we add materials so there is like zero waste from a get-go. Second one is our proprietary make is concrete free, so there is no concrete, there is no water needed, there is less energy needed just to have the same results. Another thing is the material, we already have like, a few generations of the material, and it's a natural water and air barrier. So whenever we ship the panels to the site, there is nothing needed to apply on the exterior to get to the weatherproofing. So within 5 work days, we literally can assemble a fully sealed exterior envelope, and then the subs can finish interiors. So that's how I think about the process and how to deliver more and more units. And another thing, like, the material is very lazy transmitting heat and cold, so our interior is connected to exteriors through the joints, but it's still very efficient. So all our developments are zero net energy. And on top of that, like, we use additive manufacturing, but it's only one piece of the process. We actually have like robotics to mill the surface to make it like precise, and we also do like automatic put in insulation and the coating, similar to automotive finish. I think you have like, similar process, but with traditional materials. Another thing that we allow is designers to have way more freedom in terms of what they can design, because for me, create like straight panel, or like some complex geometry or something else is the same cost. It's basically material and machine time. And designers have like full spectrum of freedom. So that's.
What are they doing with that freedom? Like, what have you seen that's different, or what have you guys been able to apply to the design?
So again, getting back to like eliminating some of the operations that needed on site. For instance, some of the headers, we can pre-print the headers as an extension of the panel just to hide some of the like, roof cassette beams, for instance. So it's literally simplify the process, and then it's reduced in hours from on-site work. That's how we can achieve this, 5 work days assembly for single-family homes that we deliver right now. That's one of the things. Another one is to use panels to like. It's going to be like we plan to deliver it later this year, but we're changing the design of the panels on the exterior, so homes can be different, basically from geometry perspective. Another thing, for instance, within the panel, it's more like, less for the architects, but more for engineers. We can pre-route the cold joints and for heat to travel, like, longer, to have a longer path to travel. So meaning within the same limitation, the wall can be more efficient from thermal perspective, which is where, like, as I said, less material to deliver the same result. That's where what motivates us, what drives us, our sustainability.
We love it. We're all benefiting from it. So thank you. All right, and thank you to your grandmother and your father. Okay, Rick, across the country, you're like we already talked about. You guys are in Boise. You are working on multi-story projects with the most automated process in the country. You really invested in the social impact, and you take I've met so many people that work with you, and they adore you, and they adore your drive to providing more affordable solutions. So I'm going to play your video while we listen to you talk about what Autovol is up to.
So we have really invested in the affordable housing sector. And what you're looking at here is you're looking at 255 units in San Jose, California. And it's a beautiful project done very well through a developer partner of ours. This is one of the models. So you can see through the interiors are very nice models. Absent the furniture, the interiors are delivered just like you see. And what most people don't realize is this is built in our factory. So our factory is 400,000 square foot. This is what we produce every day. We produce modules on average about 800 square foot. You can see the robots taking the heavy lifting off people, and people instructing the robots to work for them. And so out of that, you get accuracy, you get the precision with that. And then you see our folks here all joining in, assembling everything, finishing everything up, and then going through the end of the line, and we button it all up and get it ready to ship. This happened to have been a milestone with us, and so we marked it, had all of our people out there come in and sign off on it, and this is the building as it's being constructed. So they're being delivered on flatbed trailers to the site and then craned into place one module at a time, and then wrapped up for weatherproofing. And then what's left to do on this building is the exterior siding, the corridors, and the roofing. Everything else has been completed. Here's what's amazing. We can build in Boise, Idaho, this building that you've seen here. We can transport all these modules to the site and get those craned in set and still save them roughly $100 a square foot. So everything has to be shipped. And then there's a lot of logistics. Everything has to be planned out from the time that you start production to the way they want it delivered. They're working on the site, getting the site prepared. They're getting all that stuff done. And then they hit the go button on transportation. We ship in the order that they're going to set. And as the modules arrive, they're put in storage, and then they're all moved up, undressed, and put on a crane and stacked as quickly as possible. So we've had very much success. Our last project that we did, just to give you an idea, was 102 units that went into Northern California. And from the time that we started building the project to the time that the building was set out and ready for exterior finishes was 4 months. And that's a 4-story building in Milpitas.
Would you be able to say how much the cost per square foot is?
The cost per square foot on that was in the 150s.
And how about you, Alexey? Can you tell us what your cost per square foot is?
Right now, our cost is 300, 350, depending on the finishes. But you know, that's the material that we build with is technically synthetic stone, so it's the longevity of the material more than 50, 75 years.
Awesome. Name one thing about housing challenges that you haven't figured out that you are dying to understand better.
Oh my gosh, it's not what I'm dying. I'm dying to understand how to make it work as best as it can possibly work. And in the last several years doing this, I'm just amazed at everything I discover every day, and I'm very optimistic about where it's going and where it's going to end up.
I'm dying to see actually how policy is going to support affordable housing to make it really affordable, because from construction perspective we can drop the cost down quite drastically, and speed of delivery can be we can do it, but to market affordable will still require a lot of legwork and policy to step in.
And I'm very much in with Alexey. Understanding why don't we have the policies that can move housing through? Why does it take so long in order to approve and develop housing?
So is there anybody in the room that works on policy so we can all stare at you? Are you too afraid to raise your hand now?
Best piece of advice, I think, I received at a certain point, I was kind of previously I designed consumer electronics, robotic solutions, which is fascinating, very complex, but from engineering perspective, homes and houses is also very complex from a number of things that go in there, together with regulation, but they're all different and should meet variety of requirements. So it's a product with a certain customization that literally needs to meet the requirement, the desire for the customer who's going to be living there. So it's not using the product, but it's more be within it. So people spending life there in these buildings, that's what fascinated me. And I think I remember just had this conversation 5 years ago, and I still prefer to stick with it. Doesn't matter what the obstacles are, but that's why I'm so passionate about construction tech, real estate technology. You can see I'm investing in these categories quite drastically, and that's what's amazed me.
I think what encouraged me to stay in the industry is the fact that housing is such a need, and it's always going to be a need.
Okay, so sticking with you, Rick, one call to action to the audience.
I'm glad this doesn't have to be one word.
Oh, it does.
Oh, it does.
It's a call to action. It has to be short, punchy.
It's action. Here's what I would tell you, that everyone needs to have an address, and everyone can make an impact on letting people have an address. So talk about it, speak about it, let people know there's options.